Hello, everyone. Welcome to our exhibitor showcase titled From Risk to Reward, How bioMérieux Innovation Changes Your Operation. Today, we will be speaking about diagnostic innovation within bioMérieux with some examples related to spoilage organisms and pathogens alike. My name is Adam Joelsson. I am head of R&D here at Invisible Sentinel. We are a wholly owned subsidiary of bioMérieux located in Philadelphia, Pennsylvania. So happy to be here today.
My name is Dutta, and I'm a senior staff scientist at bioMérieux, located in St. Louis. And Adam and I collaborate on a whole lot of projects, and we are happy to be here together. So Adam, let me kick it off with a topic that you're really knee-deep immersed in, which is the ACBs, how we call it, short for early cyclobacillus. Do you mind sharing what the problem is vis-a-vis early cyclobacillus that the industry is facing, and what kind of diagnostics, if any, is industry using today to resolve this issue?
Sure, thanks, Vic. Cyclobacillus is a major spoiler in juice. So this is a bacterial organism. It's both acidophilic and thermophilic, and it forms spores. So in certain cases, it can actually survive pasteurization or hot fill techniques that are employed broadly across the juice industry. The issue here is that a subset of these species can produce a spoilage chemical known as guaiacol. Now, this produces a kind of an off sour flavor, soapy flavor. And really, if you've ever had any awful tasting orange juice, it's very likely that Cyclobacillus was the culprit there. The issue is, again, only a subset of these species are spoilers, and current methodologies, whether it's traditional micro or rapid methods, really can't discriminate from the spoilers and the non-spoilers, right? Moreover, the traditional method can take up to 7 days, and only after 7 days, when you have colonies on a plate, you can then move this to some sort of chemical analysis. There's a peroxidase-based kit you can use to identify the glycol, or you could even do HPLC on a pure culture to identify some of these spoilage compounds. But after 7 days, it's far too late, and it's far too slow to get this type of information for raw material screens coming into the production facility. So it really is paramount for these producers to get this type of information quickly. So today, Vic, we sell an ACB solution known as Veriflow ACB. It's 4-hour to 1 day test, but really the limitation here again is that we can't predict or discriminate from spoilers from non-spoilers, right? So this is really the genesis for why we're taking a look at this and making a concrete effort to solve this issue for the juice industry.
Yeah, can you speak to that a little bit more, Adam? What partnerships came along the way, and how did your team decide to work with the external stakeholders outside of bioMérieux to really take this challenge head on?
Yeah, and this is the key, Vic, for us is really responding to the needs of industry and then tapping into expertise in academia and industry alike to look at really well thought out and practical solutions. So as I mentioned earlier, we already operate in this market. We sell an ACB solution, but the number one question we receive when we're onboarding or pitching the system is, well, that's great that we can tell so quickly that we have Cyclobacillus in our product, but does it tell us anything about spoilage? And of course we say no. And then the second question we always get, well, will you ever release a product that can do that? And we say maybe, but we really are tackling this aggressively now. And we're in an interesting position with these partnerships externally and even internally within the family of companies that bioMérieux has access to. And we're leveraging these capabilities such as whole genome sequencing, bioinformatics to really drive the analytics there. And of course, our assay development group here in Philadelphia, it's really a confluence of these groups that are driving this new approach of looking at more predictive tools. So in the world of ACB, we're not necessarily the experts, right? So we really do rely on industry and academia alike. So for this project, we partnered with Cornell University. Abby Snyder, who's an assistant professor in the food science department there, is really a leading expert in food spoilage in general, but more specifically cyclobacillus, one of the few researchers working on this organism. So she's really guiding this progress in tandem with the internal groups I already mentioned. We're getting invaluable insights on the microbiology of ACB, as well as supporting our phenotypic and genotypic profiling efforts that ultimately then is informing how we produce this assay. So internally, we, in tandem with our expertise and what we're doing here, we are really poised for success here. We have identified some unique targets that correlate really strongly to glycol production. Now, I want to make a point here that it's really important that we've identified genetic elements that correlate strongly with spoilage across multiple species. This is the true innovation here. And we're in a position now where we're finishing up R&D, and this is going to be a commercial product here soon. So again, the partnerships are very important to us, both internally and externally, and the confluence of all that expertise to deliver some of these cutting edge assays.
Right. And as your colleague working day in, day out with you and your team, I have a unique vantage point to be able to see a lot of the good work that your team is doing. But if you were to quickly sort of say, what is the one takeaway for our customer that you learned from this project that we can then scale in the future, what would that be?
Yeah, most of the viewers here today probably don't have a direct relationship with cyclobacillus or the juice industry, but really the approach and the model for assay development is kind of the key takeaway and most important piece here. The capabilities we've developed internally to advance the way we think about diagnostic development is really important. So in this case, we tackled a very specific problem related to spoilage and being predictive of whether or not the organism can actually cause an issue in the product. Think about leveraging this type of process to other key problems, whether it's for a food safety pathogen, other spoilage concerns, or maybe even something related to shelf life, right? We can then work internally. We can then reach out to the key experts in these different industries to then come together and develop the best tools possible. So that's really, I think, exciting for us here and what we can do there. Right.
And if I could add to that is, we talk about this internally here a lot at bioMérieux, that we're looking for the problem statements. And if we can get those from our audience, from our customers, we feel very strongly about the kind of expertise we have in-house here, and we can put different expertise and different solutions to work to solve those problems. So with that said, I'm going to switch gears a little bit to Quant salmonella. That's the other thing that your team took on as a challenge as posed by the industry. Can you provide a quick background there in terms of why this test is critical for the industry?
Yeah, absolutely. We're excited about the work we're doing in spoilage, but pathogens are obviously a key concern and will be so moving forward. So salmonella quantification has become a fairly hot topic in various industry. The genesis for this development project here in Philadelphia was really, again, feedback from a specific client and more broadly the poultry industry. The interest was related to a very quick turnaround test for rapid quantification, but importantly, an assay that could be deployed across the production environment. Anything from primary production samples to final product, to really plug in to understand the processing environment quickly. So with those kind of design specifications in mind, we really took a look at what would it take to deliver a true single shift solution for this type of assay to quantify salmonella. And we landed on a system that circumvented the need for enrichment, delivering results in 4 hours with a 6-7 log range down to about 10 CFU per gram. Again, compatibility with different matrices was paramount. And that's really the design specifications we pursued with this project.
Right, and I can add to that there's always been solutions which are enrichment based and providing this what the industry like to call as a threshold approach or a semi-quant approach, but none of those have really been able to provide a comprehensive solution because of the biology of salmonella and the different sort of commodities and how salmonella behaves in different commodities, i.e. pork versus beef versus poultry. So it's really exciting to see that your team came up with a test that does not require enrichment. So at least it takes that component out of the equation. So when you're spitting out a number, it's a little bit more direct. Can you speak to the assay a little bit more? Like, how are you calculating how are you providing the quantification of salmonella in your calculations?
Yeah, absolutely. And you bring up a great point. One of the advantages we realized and keyed on early on is, again, the variability in growth rates of different serotypes. For example, stresses, cold storage, even the impact of the matrices, as you mentioned, can greatly slow or enhance growth of salmonella. So a direct sampling method that we employed, and I'll get to that in a moment, just proved to be, in some cases, inherently more accurate or precise in terms of the enumeration. So in terms of how we handle this system, we do harvest the bacteria from a sample. We do that through centrifugation, and so we can concentrate that sample, and then we extract that DNA. From that, we run a PCR, a real-time PCR reaction, and from that, in the event of a positive, we'll get a CP value or a crossing point value or quantification value, sometimes it's called. And from that, we compare that to a standard curve, plug in the value, and then we get that enumeration in CFU per mil. But it's important to note here that this is derived from gold standard MPN methodologies. So that's how we generated the standard curve. So in essence, this is a quick replacement for MPN across a wide range of different.
Right. So you're sort of shortening the time to getting to that MPN-like number, which then allows people to make, or folks to make, a more informed decisions about the salmonella load or interventions or whatever they're looking to do. Yeah, and it goes across the whole production chain, right?
Exactly. So inherently, this is a different approach than a qualitative plus minus answer. When you're looking at a presence absence test, you can't tell the difference between 1 CFU on a carcass or 10,000 CFU on a carcass. It gives you the same result. This is intended to be really granular. You can see how well your intervention techniques are working, for example, and you can plug this in all along that processing environment to gain a better understanding of what's happening specifically for salmonella in your plant, for example.
Right. Adds another layer to that risk equation and therefore make informed decisions.
Yeah, absolutely. So we're excited about this. It's currently moving through regulatory approvals, and we should see this on the market shortly as well. Focusing in on these different things, pathogens, spoilage organisms, and how we're driving innovation, I think it's really interesting. E. coli, Vic, as you know, has been a huge challenge to really advance and kind of move that type of testing forward. From a regulatory standpoint, industrial standpoint, and even on the technology side, has been very challenging. I know bioMérieux has been working on several solutions. Would you be able to touch on how bioMérieux is positioned to help in this area?
Yeah, sure. So the Shiga toxin, or the pathogenic E. coli, Shiga toxin producing intimate positive E. coli or the pathogenic E. coli have been an issue for the produce industry as well as for the beef industry, the meat market, worldwide, globally. And it becomes a little bit more critical because of the adulterant sort of status that is given to the pathogenic E. coli, more specific, the top 7. So for a while now, this sort of policy has been made, and it's been out there in the world, especially for the beef industry, to sort of test against. There's not been really a good solution to sort of address this problem. And there's multiple reasons for it, but the problem manifests itself as false positives most of the time. And that's been, I would say, primarily driven because of the technology flaws. And it starts from the genomics. We didn't have good genomics in the first place. And then the methodologies have also sort of, developed over the years. And now I think we are coming to a place where we can offer something that at least detects well. But then it doesn't take away the problem of the mixed broths, where you get a Shiga toxin gene from one of the bacteria and the intimate from the others. And the combination of the two is what the definition of the pathogenic E. coli is. And then so how do you parse that from a true pathogenic E. coli where it has both of the genes?
That's really been the key issue, right, Vic? The false positives,
absolutely.
STX in one organism and EAE in another organism, and then having to follow-up work to qualify. A huge challenge.
Exactly. huge, and we have heard numbers up to 90% false positive rate, which is obviously a huge waste for the lab, but even bigger waste for the industry because of the adulterant status of the pathogenic E. coli for the top 7 serotypes. You're stuck with holding on to the product, and that's not good for anyone. So that's another sort of, becomes another problem because from the food wastage standpoint and the economic losses, of course.
So obviously there's significant resistance in industry to pursue STX-EAA testing for those reasons.
Yeah, that's been the biggest sort of roadblock, and we consider ourselves as a technology partner for the industry, and we sort of took this upon ourselves to figure out how exactly should we, or what is the best way to tackle this. And so that's been sort of our mantra for a while. Make sure that we do a good detection, which means every time our genes, our PCRs are picking the right genes, and they're doing it well 100% of times. And then the second piece is solving this mixed broth problem, for which we are hoping to launch a solution soon at the IFB.
Okay, can you touch a little bit on how that's being resolved on the technology side, and really how it was originally conceived, and some of the critical partnerships, again, keying in on kind of that theme and how we got to this point?
Right. So it's too big a problem for us to solve on our own. So we reached out to our partners at Ansys, who were trying to solve the exact same mixed broth problem for over a decade now. And interestingly, they had keyed on certain genes that tend to show a genetic co-localization of Shiga toxin and Entomin genes. So essentially, if you are detecting these genes in addition to Shiga toxin and Entomin, which is the regulatory definition today, then you're running into a pathogenic E. coli. And so we sort of took those genes and the knowledge base there and turned them into assays, which are sort of, formatted into our regular GENA PCR format. So when you're essentially running it in the lab, you will just add another assay right there when you're doing the Shiga toxin Entomin testing. And then a positive result there is a very strong indicator of the pathogenic E. coli, i.e. the genetic co-localization of Shiga toxin and Entomin genes. And before we went to that stage, the way we really sort of beat this up to make sure that it's going to do what we expect it to do is through our internal expertise within bioMérieux in the field of bioinformatics and data science. Excellent scientists that we have, whom I'm very proud to call them our colleagues, and they are very quickly able to ramp up the test analysis. In other words, how many times do you see, in this case, do you see these genes pop up when you have a Shiga toxin and Entomin gene? And we found that correlation to be very strong, i.e. 99%, that was tested across almost 25,000 genomes. And that is sort of the other piece that we are sort of, we are entering into this era where, the good old, let's go test in the lab, everything empirically be done, sort of gone out the window, because we're able to quickly scale these things up digitally in silico and we kind of know by the time we start messing around with things in the lab, what are we going to expect from assay. So that's the kind of thing
You're leveraging those internal capabilities, and again, that's the same group that really drove the analysis side on cyclobacillus and how we kind of chose these targets moving after it. So that piece of it is really cool. But let's stress, this is going to be a solution for the market, these new markers.
Right.
It's going to be a to use assay that gives you this information as if it were any other qualitative assay.
Exactly. And the value there, the goal there is that as our end users are getting plus minus from these assays, combining the data from the what we call as pathogenic E. coli, the PEC assay, in addition to the Shiga toxin and Entomin gene, you'll be able to make more informed decisions in real time. So you're really trying to take out the risky pathogenic E. coli out of the food chain, and therefore really making your food safer and be confident about what you're putting out there in the market.
So excited about this. We're truly moving the needle here, I believe, and it's going to have an impact. Just broadly speaking, Vic, when we discuss moving the needle in pathogen testing, there's a certain amount of inertia there against other organisms as well. We already touched on a unique solution for quantifying salmonella, for example, but how do you see these types of approaches influencing testing of other organisms beyond just E. coli in the pathogen space?
Right. I think it's the leveraging of the in silico resource of the bioinformatics, and then combining that with your expertise on assay design and And of course, following it up with the best formats that we can give to our customers is the key. And you touched upon it early on in our conversation that it is going to be a multi-systemic, multidisciplinary approach to really provide the right solution to our customers. And we are sort of clubbing that under the word innovation, which is at times overly used. But in this case, I don't know any other way to design the systems that truly provide meaningful results to our customers without using sort of, this different level of expertise at different layers as well. So to me, that is the way to harness the future, and I think we're on the right track. Absolutely excited about it.
Couldn't agree more. It's great being part of this organization and working on these tough problems. But we are releasing practical solutions, so we're backing up our rhetoric with great tools. Excited to see it.
With a lot of speed, thanks to your team, with a lot of speed. I mean, traditionally, these kind of things takes months, if not years, to be put out there in the market. But thanks to a lot of the work that your team has been doing, we're able to very quickly react to the market needs. And to me, that is the way to leverage innovation.
Yep, absolutely. So I'm hoping we're communicating and getting across that we are interested in pursuing these tough problems. And we can do so on a custom basis as well. If you'd like to learn more, we have a booth here at IAFP and resources on the web. Vic, you want to maybe touch on that a little bit more here as we wrap up?
Sure. For our audience, this is something that we are this is not a one-off thing. What Adam and I are sharing with you is not just a case study. It is a pattern of how we intend to go about solving problems. So we really need your problem statements. Please feel free to reach out to us. No problem is too small. We can't always give our best shot at it. And I think we are positioning ourselves, given all the expertise, to really take a hard look at the way things have been done in the past and really come up with a really innovative solution that can provide real-time intelligence and information that really makes a difference for you on the ground. So with that said, yeah, as Adam said, please reach out to us, to our team members here at our virtual booth. And with that, Adam, thank you so much again for your time today. And we'll look forward to seeing you at the IFP.
Absolutely. Always great chatting, Vic. Thanks so much.
Thank you.